Chavan sir, with your prior permission, I'll just share my screen for 1 minute, and
Yes,
after
yes,
that I'll okay.
yes, yes.
So is my screen visible?
Yes, madam. Screen is visible.
Okay, sir. DK sir and Dhonde sir. So shall I start with the session, sir?
Yes, madam.
Okay, sir. A very good afternoon to one and all present over here. I, Ms. Payal Taire, Assistant Professor from E&TC Department, on the behalf of AISSMS COE, welcome all of you in 1 week online faculty development program on recent trends in machine learning under the aegis of IET Student Forum, ISF, and Professional Activity Center of IET. To upgrade our own values, knowledge, and skills, you should always be surrounded by an eminent and intelligent people. Today, we are very fortunate to have a company of such an intelligent personality with us, with the name as Dr. Umesh Chavan sir. Sir is currently working as an assistant professor in Information Technology Department, Walchand College of Engineering, Sangli. Sir has completed his PhD in Computer Science and Engineering from Shivaji University, Kolhapur in the year of 2022. Sir is having total 6 years of industry experience and 26 years of teaching experience. Sir is having the mastery on few technical skills such as Python, MATLAB, OpenGL, Prolog, R programming, etc. Sir has taken various key courses also in digital image processing, parallel programming, machine learning, advanced computer graphics, and on theory of computations too. Sir is holding various positions in his career, such as he is currently in the Board of Studies in Computer and Engineering, Shivaji University, Kolhapur. He is also acting as the Deputy Controller of Examination at Walchand College of Engineering, Sangli. Also acted as the head of the Department of CSE in Bharatiya Vidyapit College of Engineering, Kolhapur, and as well as at the SVPMS COE, Malegaon. Sir also received fund of $1,500 from Georgia State University, USA. Sir has published 9 research papers in various journals. We are very glad to have you, sir, as a speaker. So without any further delay, I request Dr. Chavan, sir, to take over the session. Over to you, sir.
Thank you, madam.
Thank you.
His screen is visible. Presentation is visible.
Yes, sir. It's visible.
Okay. Thank you, madam. Hello and welcome to all for this workshop on recent trends in machine learning. Myself, Dr. UP Chavan, and I am honored to be your presenter for today's session on deep learning applications in computer vision. So the application domain or the topic that I selected is a facial expression recognition, or it is also known as a emotion recognition. The input for this application is either image or video, because video is nothing but sequences of images that is known to you. So facial expression recognition is a rapidly growing field that has wide applications in various industries such as psychology, human computer applications, and security. With the advent of this technology, deep learning, we have witnessed a revolution in the field of facial expression recognition, enabling us to build more accurate and efficient models. What is the model? We will come to that issue, that can recognize facial expressions with high precision and quicker. In this workshop, we will discussing the fundamentals of facial expression recognition using deep learning, including all stages of machine learning and deep learning, that is data collection, reprocessing. Important thing is to build the model, to train the model, to evaluate the model, and its applications of that topic, facial expression recognition. By the end of this workshop or this topic seminar, you will have a comprehensive understanding of the basic concepts and techniques used in facial expression recognition using deep learning. And also, we will be equipped with necessary tools to start building your own model. So that also we will discuss. So let us dive and explore this field of facial expression recognition using application, rather than the subject name is deep learning applications in computer vision. So this is a introduction. So already I'm not sure, but somebody had covered a convolution neural network, or CNN, is a class of deep learning or a deep learning model or type of deep learning model, which is a type of feed-forward artificial neural network. Now, all of you are aware about ANN, or why it is known as feed-forward ANN, and deep learning is a subtype of ANN which has deeper means number of layers are more, because in basic ANN there are only 3 layers. First layer is input layer, last layer is output layer, and only one hidden layer. That is the architecture of ANN. But deep learning is a architecture based on different blocks of layers. So why CNN is important? Because convolution operation is very important in image processing or computer vision to detect the feature. That feature may be anything. For example, I want to detect only eyes. I want to detect face from the given image. I want to detect only eyebrows. I want to detect only chins. I want to detect edges. To detect all these features, we require different convolutions, filters. So that is the basic that we learn somewhere in image processing or in computer vision, or that is known to you. Then coming to CNN, basically, there are 3 types of layers used in convolution neural network. One is input layer, that is required in ANN also. Another is the output layer, that is required in ANN also. But it requires different or multiple hidden layers. And those layers are primarily convolution layer, pooling layer, and fully connected layer. Out of this fully connected layer is nothing but the hidden to output layer in the neural network. It is not different. But what is main important layer is the convolution layer. Pooling layer is also important, but the time consuming tasks are more tedious tasks required, or more competition required is in convolution layer. Why? That we will see in the next slide. So refer this one sample block diagram source I mentioned here. Assume that this is your image. This is your image of size n by n. Okay, and just consider this is your convolution filter. Mostly this filter size is odd, like 3 by 3, 5 by 5, or 7 by 7. Now, the here you can first we'll go through this architecture. After this input layer, the layer added is a convolution layer. So here we will apply this filter number of times. In this case, 1, 2, 3, 4, 5, 6, 7, 7 times for this image. So total number of filters applied here, one filter but 7 times, and this will repeat it. So it will do the convolution. That convolution is a mathematical operation that we will see. So this square will be scanned from row and then column wise. So it will create a blocks of this size of filter, and each block will be processed sequentially. So this block will slide from left to right, then again top to bottom. So that will times it will repeat for one, and we can say that these are the features. So this will extract the features. So this is the technically the task of convolution layer. After convolution, another layer required is a pooling layer. Pooling layer is nothing, not difficult to understand. Suppose your image is of size 12 by 12, and if you apply pooling 2 by 2, that block or this feature will get scaled half by half. Okay, so here if it is 10 by 10, it will become 5 by 5. If you applied average filter, what it will do? It will create the blocks and it will calculate the average of all pixels. Or sometimes it will use max filters also. So what it will do? In this block, it will pick the max intensity value pixel and it will replace that block. But overall, what it will do? It will reduce the size of the feature. So obviously, if your processor is processing with this large image n by n or 100 by 100, and if you convert it in with 10 by 10 by maintaining features, it will easy to process. It will be compact to process, and it will be faster to process, because you know you have so many number of filters, so many neurons, so number of parameters to train are huge, and to train or to detect or to process, it will require more time if your image size is more. So the pooling layer will do the reduction of the size without changing the information or content. It will just make half, but by doing the average of its neighboring pixel. So doing this pooling is not a computationally intensive task, because pooling is very simple. What you have to do, you have to find max value or you want to find average value. So there are a lot of C functions or Python functions already available, so it will not take more time. But convolution, you can see that it is a computationally intensive task, because for just one feature you need to repeat so many times, and like this way you need to repeat so many number of times, which is required huge intensive. So using parallelization techniques or GPU techniques, we can do this work parallelly, so that training time will be faster. So if somebody experimented without GPU, the training time will require more than 10 times if you use GPU. So what the GPU will do, to one GPU thread, it will assign this task. To another GPU thread, it will assign. And like this way, it will do parallelly. So that speed up is also achieved. If you are interested, you can do the research without GPU, how much time will require for some task, and with GPU, how much time or how it will accelerate, or you can calculate the efficiency or speed up. So that is the due to this availability of high-powered GPU, and so that now deep learning is becoming more popular, because in old days, just to train a small task, it will require days and days, and that is not possible. I want to mention here the result of my task. For 30 epochs, I require near about 3 days to train my deep learning model, but the same task I achieved within 4 hours with the GPU. Why? Because this task is independent. If you say suppose I am doing convolution in this region and somebody is doing convolution in this region. These two regions are independent. So parallelly it can be done. And so that using GPU or another parallel computing techniques like OpenMP, MPI, we can achieve speed up. So number of times you referring that use GPU. Even those who are using Colab or Kaggle, you can check if you train some network and if you connected GPU provided by that Kaggle or that, it will be faster. And that is the why, because this is the technical or basic reason behind it. Now, this is regarding convolution layer and this is regarding the pooling layer. The output of pooling layer is connected to the layers in the next layer, that is a fully connected layer. Why this layer is known as a fully connected layer? Already you are aware about, but I want to once again mention here if somebody is interested. This is the output layer. Every neuron in this layer is connected to every neuron in the output layer. Here you can see in the diagram. So we can say that the connection between this layer and this layer is fully connected. So the last layer is always fully connected layer. And this layer is nothing but as like your ANN. Because in ANN you have this layer, output layer, and before that a layer which is connected to output layer. In CNN it is known as a fully connected layer. So don't worry, overall we require three types of layers: convolution layer, pooling layer, and fully connected layer. Out of this, fully connected layer is actually not new type. Pooling layer already discussed, but what is the convolution? If you know, once again we will go through it. Okay. Now here you can see that before fully connected layer, the task of convolution and pooling layer is to extract the features. And after extracting the feature will be get inputted in this layer and it will do the task of classification or whatever the different tasks like detection, regression, or whatever it may be. So here you can see that the basic difference between machine learning and you can identify the difference between machine learning and deep learning is that in machine learning, these layers are not exist. These layers are not exist. So the task of extracting feature, you have to do manually. You have to do manually. And then after extracting the feature, you need to input the features to the your ANN and then we'll do the task which is similar. So that is the big difference between deep learning and machine learning. Once again, I am repeating. In machine learning, this feature extraction task is to be done manually, whereas in deep learning, this feature extraction task will be or that role handled by convolution layers and pooling layer. Another important thing is here in picture you can see only one layer of convolution, one layer of pooling, but in practically you require stacks of convolutions and pooling layers or sequences of convolution and pooling layers. Then only it will extract the features, because you cannot say that only I is an important feature. Why? Because for example, in facial expression recognition, only eye is not important feature. I required another features also, mouth position or shape of mouth or another important features, eyebrows, everything is required. So it is not necessary to only one extract feature. We need to extract multiple features. And if you want to extract multiple features, only one layer of convolution is not enough. So you require sequences of or stacks of convolution and pooling layer. So your network will have input layer, output layer, fully connected layers, and sequences of convolution and pooling layer. And so that your network is now deeper. For ANN it is shallow, but for deep learning comparatively it will be deeper. Deeper means more layers, and so that it is known as a deep learning. Okay. So what is a convolution layer? Just give me 5 seconds. So what is a convolution layer? Computers read images as pixels and it is expressed as matrix. All of you compatible with this? What is an image in short? Image is nothing but square matrix and element in that matrix is nothing but pixel value. Okay, all of you aware about. That obviously matrix has rows and columns, number of rows and columns, or it is known as height by width. Convolution layer consists of set of learnable filters. Now, what is this? What is filter? Filter, kernel, all are equivalent words. So, convolution layer consists of set of learnable filters. Every filter has small height, width, and some depth as that of input volume. Now, skip this depth because it is related to 3D. Means for video processing, you require third axis, that is with respect to time. What is a filter or what is a kernel? A filter is applied to an input image to detect the presence of specific features or patterns. Suppose from the given image, I want to detect the presence of eye. So I will apply that convolution, and at a specific location at eye position, it will detect that there is eye. Or another example, if some image of person is there, after applying filter, it will detect the position of face. Face means it will identify the bounding box and it will get those XY coordinates. How? So by applying these filters, it will detect the specific features, required features. Okay. Different convolutions are used to extract features like edges, lines, and highlighted patterns from the image. Madam, everything is okay? Am I audible and slides is okay? Hello? Hello, madam? Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Audible.
Okay, and slide is visible now?
So just now, before 1 minute, the slides were visible. Now it's visible, sir.
Yeah, okay.
Yes.
Next layer is pooling layer. The main purpose of pooling layer is to reduce the spatial size of the image. Already I discussed. Suppose your input image is of size 10 by 10, and if you apply average filter or max filter of 2 by 2, it will divide the image in two halves. So 10 by 10 image will become 5 by 5. Okay. This layer basically reduces the amount of parameters. Obviously, instead of 10 by 10, you require 100 parameters, and if you apply the pooling layer, it will convert into 5 by 5. So you will require 25 parameters instead of 100 parameters. It takes smaller blocks from the convolution layer, and it is also known as a subsampling procedure. Already I discussed there are two types of pooling operation. One is max pooling and another is the average pooling. What max pooling does, as the filter moves across the image, it selects the pixel having maximum value to send to the output array. Means what? In a given neighborhood region, suppose 8 neighborhood concept means 3 by 3 image, 3 by 3 filter, total 9 pixels. In that 9 pixels, it will select the maximum filter pixel value and it will replace that middle pixel with that maximum pixel value. That is done in the max pooling. Whereas in average pooling, what it will do, it will calculate the average of all those 9 pixels and replace that middle pixel value with that calculated average value. So that is the task of pooling, which is computationally not so intensive. So this makes why we are reducing the size of input image, because this makes computation fast and obviously reduces memory and also prevents overfitting problem that we occurred mostly in machine learning tasks. Then the next, rather than the last layer, is a fully connected layer. So this layer performs the task of classification based on the features extracted through the previous layers. Rather than, you can see, the task of this fully connected layer is actually do the final task, that is classification, and it will get a feature from all from all previous layers. So it will extract the features, and that feature will be provided in the fully connected layer, and fully connected layer will do the task of required task like classification in this example. So here you can see diagrammatically also. Here you assume that this is your input filter, input image, and as here you can see that 1 2 3 4 5 1 2 3 4 5 5 by 5 image, and here you assume that it is one convolution applied of size 3 by 3, and initially first it will place on this and it will replace this 75 value with that convolution operation. Then filter will be moved to the next region, and then again the procedure will repeated, and you will get this blue shaded output. And here you can observe that your input image is of size 5 by 5. Your filter applied here is of 3 by 3 size, and the actual output that you will get is 3 by 3. Once again, I am repeating, this is very important in convolution. If your input image provided before convolution is of size 5 by 5, you applied convolution filter of size 3 by 3. After convolution or after filtering, the output will be of output picture will be of size 3 by 3. Why? That we want to discuss. Anybody know reason? After convolution, after filtering, convolution or filtering, it will reduce the size. Can somebody on chat give me reason why it is reducing the size after doing the convolution? Or you can discuss here also. Can somebody tell me the reason why after convolution size of image will get reduced? Not pooling layer, I am saying about convolution layer. Rather than go with the technical, after doing convolution, why it is anybody can share answer? Okay, so continuing, at least you observe here that size is getting reduced. That is with the convolution layer, and pooling layer already we discussed. Rather than try to watch this overall process in the convolution neural network. Suppose this is your input image of so many number of pixels, and after applying convolution, it will extract these features. So first filter will extract these features. Second filter means, already I discussed that it can apply multiple filters. So this is the first filter, it will then second filter, then third filter, then fourth filter, like that way. After extracting the features, it will be get pulled. So what pulling? It will just reduce the size of this feature maps. It will reduce the size of this feature maps. And like this way, there are sequences of layers like convolution layer and pooling layers. So here you can see that multiple features are applied, and it will extract the features, and it will get the output as a feature maps. So in this case, it will extract 6 features. So you require 6 features that will apply to input image, rather than you applied filter convolution 6 times. So you will get 6 feature maps, and in each feature map you are extracting different features. So in the first feature map, you extracted only edges. In the second, you extracted blue part, and like that way. So this will be done automatically. Means your that deep learning algorithm will decide the parameters, and it will extract the required features related to your task. So in between this input and feature map, there are convolution layers. After convolution, after extracting feature maps, next layer is the pooling layer, and the task of pooling layer is just to reduce the size. Okay, just to reduce the size. So here you can see that it is just making downscale. So it is known as a downsampling also. This pooling layer is also known as a downsampling. It reduces the size, but it will not change the contents. It will just compress the this feature. Okay, so if you compress it, or if you reduce the size, computationally it will be faster. Okay, so that is the task of pooling layer, and like this way it will go through convolutions, pooling, again convolutions and pooling, and at last whatever the features extracted, those features will provide to convolution fully connected layer. So here you can see that at the end, just a bit, at the end, these extracted features will provide to fully connected layer, and it will do the classification. So this is the flow of working of typical deep learning network or deep neural network, or known as a DNN. So now you can in one line we can say that input is provided to input layer, output is at the output layer, there is a fully connected layer that is connected to the output layer, and between input and fully connected layer there are blocks or layers of different convolution and pooling layers. So this is a typical architecture of deep neural network. In short, try to remember that or try to visualize that deep learning model, deep learning network is having 3 important blocks or layers. One is input layer, another is a convolution layer, pooling layer, fully connected layer, and output layer. Out of those, input layer, fully connected layer, and output layers are always there in NN also. In addition to that, it requires convolution layers and pooling layer. So what convolution layer is doing? It is doing convolution, or in image processing it is known as a filter. Convolution is a mathematical term, filtering is a specific to image processing term. So convolution or filtering both are equal. Okay, so if you are fine with this basic introduction, we will go with some techniques. Is it visible? Slide is visible?
Yes,
Madam,
sir.
slide
It's
is visible?
visible, sir.
Okay, okay. And audio is okay?
Yes, absolutely fine,
Okay,
sir.
okay. So now my previous question was why it is means we will go with a simple convolution operation. Assume that this is an image, and assume that this is a color image. So basically, technically, mathematically, it requires 3 matrices: one for R values, one for green values, and one for blue values. So assume that this image is of size 6 by 6. So actually, matrix will be 6 by 6 by 3. So height is 6, width is 6, and three stacks means red plane, green plane, and blue plane. Rather than these are number of channels. If it is a color image, it 3. Otherwise, if it is a gray image, grayscale image, then it is 1. 6 by 6 by 1. So assume that this is your input image, and this is your kernel or filter. Assume that this is your kernel or filter. The kernel or filter is of size 3 by 3, but I required 3 filters to apply separately for each channels. So I required 3 by 3, like this way I required 3 filters. So here you can see that volumetric dimension is 3 by 3, but I required it 3 times. Okay. So obviously this should match. This can be anything. You can apply 3 by 3 or 5 by 5 also. Okay, depending on requirement. But mostly it should be of odd size. Once again, focus. This filter should be of odd size. Why? There is a technical reason, but this is not a platform to discuss because it will take time. That is part of image processing or image convolution. But just note down is that this filter, this convolution, that size should be always odd. Okay, and don't take like 3 by 5. Take it square, 3 by 3 or 5 by 5 or 7 by 7. And mostly it is suggested, recommended, get a square image. Means don't take image like 10 by 6. Take it square image. Otherwise, it will not get matched. Then what it will do? Suppose I applied this filter. So this is a 3 by 3 filter, or mathematically it is a matrix. So assume that this is one matrix and image is another matrix. So these are the elements of this matrix. Which matrix? This filter matrix or convolution filter. Assume that these are its values: -1, 0, 1, -1, 0, 1, -1, 0, 1. And for G, I don't want so make it 0. Blue, I make it 0. Now, what I will do? I will just give me 2 minutes. I will show it by with ink. What I will do? I will place this kernel here, and purposely I will make it short here, expanding. Assuming that the pixel value is P1, here P2, here P3, dot, 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 here P9. These are the pixel values of image, and these are the kernels. Okay, these are the kernels. So I will place this kernel over here. I will show it diagram, and I will place this kernel here. Okay, so this kernel is also of 3 by 3 size. Now what you will do? You do the element wise production, element wise of product. So P1 into -1, P1 into -1. So I will write it as a minus P1 plus P2 into 0. So, okay, no issue. P3 into 1, P3 into 1. Again, if I repeat this, it will come minus P4 plus P6. And P5, P6, this is P7 minus P7 plus P9. Am I right? If you do this sum of products, P1 into -1 plus P2 into 0 plus P3 into 1 plus P4 into -1 plus P5 into 0 plus P6 into 1 plus P7 into -1 plus P8 into 0 plus P9 into 1, you will get this. And here you can see that it will do difference between next column and previous column. So here you can see that P3, P6, P9 are all in the next column. If you are focusing on this column, this is the next column and this is the previous column. Rather than with respect to image processing, what it will do, it will get the difference between next column and previous column. And if that difference is bigger than some threshold, you will mathematically tell that there is a drastic change. abrupt change. Abrupt change in any sequence of data is nothing but edge in image, and that will useful to detect the edge. So if I apply this filter, sorry, if I apply this filter, it will detect all vertical edges in the R channel, because I not applied on G and blue. So if I apply same filter 3 times, then obviously what it will detect? It will detect all vertical patterns in R channel as well as in G channel as well as W channel. So just by applying this filter, it will extract all vertical features in red channel, in green channel and blue channel. And this is the importance of convolution. So here I have shown that this sum, and you will get that output here, and you will get output here. Now the question is, here input size is 6 by 6, but output size is become 4 by 4. Once again, I want to repeat that question. So if I apply a filter of size 3 by 3 to the image of size 6 by 6, after conversion it will become 4 by 4. Why? That was my question. So can somebody again now with this illustration can able to explain why it is? Why it is? So this 6 by 6 is converting into 4 by 4 after evaluation. Why? That is my question. Okay, somebody, please try. Because that we learn in image processing, no? Convolution. Anybody knows answer? Question is once again I am repeating. Why after convolution this 6 by 6? Skip this 3 times. After applying convolution of 3 by 3 to the input image of 6 by 6, output 4 by 4. Why? That is the question. Okay, I will give the reason. This is your input image. I will make it smaller. Suppose you want to process this pixel. You want to process this pixel. Here I am showing. So assume that you are using 3 by 3 filter. So I will place this filter over this processing pixel. Okay. So this is my kernel. So I will place this kernel here. Okay. And assume that this pixel's value are P1, P2, P3, P9. And these are the actually kernel values. So what I will do, P1 into -1 plus P2 into 0, that already discussed. Now see from the beginning, because we are starting from the top row. So initially you will place this kernel here. So place this kernel here. So your kernel is like this way. Okay, like this way. Okay. So rather than this kernel, you are placing here. So here, actually this pixel is where in your image? It is in the second row and second column. So this is that. So you are doing this convolution operation or surround this neighborhood, and you are replacing this pixel value with this convolution operation. But what about this? You are not processing these pixels. You are not processing this pixel, as well as you are not processing these first row pixels also. If you repeat this, so this one row, one column, before, after will be get removed. So instead of 6, the bottom one row will not get processed, top one row will not get processed. So 2 rows will not get processed. So 6 will become 4. And similarly, first column will not get processed. Second column is pixels will not get processed. So one first column and one last column will be not get processed. So from 6, first and last column will not get processed. So though 6 minus 2, that is a 4 by 4. But this depends on how filter size. If you apply 3 by 3 filter, the 6 by 6 will become 4 by 4. So there is some formula to calculate the output size after filtering or after convolution. So 6 by 6 will become 4 by 4 when if I apply filter of size 3 by 3. But if I apply filter of 1 by 1 size, then it will not change now, because I can place whole kernel here. I can process first row, first column, as well as the last column. So size will not change. But if I apply 5 by 5 filter, again my output will not be 4 by 4. It may be like 3 by 3 also. So how to measure this size of output after apply convolution? There is a formula. But important issue here I want to discuss is that what is a convolution operation? And mostly this convolution operation, the filters of these convolutions matrices are of size order. Here for illustration purpose, I refer 3 by 3 filter. Okay. So in continuation with presentation. So here see the same similarly is repeated here. If I apply this filter, I will extract the vertical features. But if I apply this filter, obviously what it will do, it will refer previous row and next row. Rather than in image, if you are in this row, it will get the difference between next row pixel values and previous row pixel values, rather than it is related to horizontal edge. So if I apply this filter, it will detect all horizontal features edges. And if I apply this filter, I will extract the vertical. This is what? This is nothing but convolution. So it is not what we can say that cross or multiplication. Here it is mentioned as star, because it is doing dot wise multiplication of matrices. P1 into this plus P2 into this. It is doing element wise. So symbol for convolution is star. It is not multiplication symbol. Always remember that convolution symbol denoted as star. So this star indicates convolution. So in this example, I applied 2 different types of filters. One is vertical filter and another is a horizontal filter. And like this way, I will apply for each layer, or sorry, for each plane separately. So here 3 planes. So I apply 3 filters of vertical. Apply another, because I am not sure whether I require only vertical features. Maybe my image required horizontal filters also. May my image require, means my task required combinations of vertical and horizontal filter. So you apply all filters of convolutions, means all types of feature extractors depending on your task. Maybe in this task I required combinations of vertical and horizontal features. So I apply convolution of vertical and convolution of horizontal. And this is achieved using convolution layer in deep neural network. So this convolution is very basic operation. Now see here, for this small image, for one operation, there are 3 by 3 kernel. I require 9 products like P1 into -1 plus P2 into 0. So I require 9 times. And this I need to repeat 4 by 4 times now. So I will slide the block, then I will slide the block, I require 4. So 16 into 9. So many times I require this operation. And here image size is 6 by 6. But if your image is of 10 by 10, so many number of computations required. So my claim is that convolution requires huge computations. Though it is repetitive, it requires huge computation. so that more time in your training of neural network is invested in convolution operation rather than pooling operation. So here also you can see now with the example. Assume that this is his image of 1, 2, 3, 4, 5, 6, 6 by 6, okay, 6 by 6, same, and you applied this filter of 3 by 3, and assume that these are the pixel values. Obviously, this is a vertical extractor. This is another extractor. I don't know because I will not provide the filters. Deep learning will automatically decide these parameters, and that is the task of training. So these parameters that after training the deep neural network, it will decide these parameters, and that is the objective of training the deep neural network. Now see what is the procedure. Initially you place this kernel over here. So your operation is 4 into 1 plus 9 into 0 plus 2 into minus 1 plus 5 into 1 plus 6 into 0 plus 2 into minus 1 plus 2 into minus 1 plus 4 into 0 plus 5 into minus 1. Let us see. Let us see. Okay. And actually, it is not okay. But that, like that way, it will complete the operation. Now, in previous slide, I mentioned that after convolution, the 6 by 6 will become 4 by 4. And here our filter applied is 3 by 3. So I mentioned that there is a formula. So we will go through that formula. Okay. Assume that F is the filter size. P is a padding. There is a padding constant. S is the stride, and NC is the number of filter. What is this parameters in deep neural network? Once again, I want to get help of this pen. Let us see. Suppose this is your image of n by n size. Just for example, n by n size. Mostly it is square, and you are applying this filter. And the size of this filter, here it is 3 by 3, but assume that filter size is F. Filter size is F. F means F by F. F by F. Okay. Filter size is F by F. And padding size, what I told, if you apply this filter, you are keeping this filter over image, and this will be matching. You will matching this pixel with this middle value. But what about this pixel? You are not processed. So technically what you are doing, you are adding one row and one column to the image rather than padding one row before, one row after, one column before and one column, and keep maintain all elements 0, 0, so that the size will not get reduced. So this is a padding. This is known as a padding. So padding size, how many rows you are padding? Here 1. So that is also one case. Stride means what? After doing this task, you are moving this kernel to the right side. So by how much we can say that rows, columns. So that is the stride size. And already I explained number of filter. So these are the required competitions. One is filter size, padding size, stride size, and number of filter. And with this, you will get what is the size. N is equal to N plus 2P minus F divided by S plus 1. In our case, means just refer previous example. N was 6 now, because your input image was 6 by 6. F was 4. F was 4 because you are sorry. F was 3 because you are applied 3 by 3 filter, 3 by 3 filter, and we not padded anything. So P is 0, and stride factor is 1 because once this block is processed, we go to the next block. So you are just moving by 1. So stride was 1. So we will put it this in formula. N is 6 plus 2 into P 0 minus F is 3 divided by 1 plus 1 because S is 1. So 6 minus 3 plus 1, that is 4. So our calculation is correct, that we got it 4 by 4. So like this way it is simple. Just put the parameters, because when you are deciding the convolution filter, at that time filter size is fixed, and depending upon the policy where you are padding by 0 or not padding, then p is equal to 0 or 1. If you are being padding, p is equal to 1. Otherwise, if you are not padding, p is equal to 0. Stride size is mostly 1 if you are moving by only 1 unit. If you are moving by 2 unit, then means by going by 2 pixels, then s is equal to 2, and total number of filters in convolution that is known to you, and you put this equation, that will give you the output size of the matrix. Okay, so once again, in our example, it is 6 by 6, filter is 3 by 3, and we are moving by stride is 1. So by putting in the formula, we will get 4 by 4. That I demonstrated. Okay. So by this way, you can calculate the number of size of the output feature after convolution. So this is the most important, and you need to focus only on this convolution operation in convolution layer. Forget about operation in pooling layer. And for fully connected layer task, that already we studied in ANN. So if you are extending your knowledge to deep learning from ANN, you only focus initially on convolution layer. Once you got the basic science or requirement of the convolution in convolution layer, then deep learning is just a thing to understand. Okay. So this is slightly theory. Those who are first time observing it, it is slightly faster, but there is no choice to keep balance. I have to go with this speed, but you may contact to me anytime regarding additional information related to this, because our main objective or focus is not this, but to maintain consistency, I covered all these topics. Now, though it is technically looking so many, I mean, not so easy, or it may be more engineering, but from the applications or programming point of view, it is simpler, because lot of tools available to us, and we are fortunate that in Python, or mostly libraries are provided, which makes this task simpler and easy to applicants. I'm not saying programmer. For applicants, it will be easier, rather than for the applicants or end users, it is just a black box. Deep learning neural network is a black box. I will provide the input and I will get the output from the black box. Though you can also, maybe you are using it as a black box, but as an engineer, you go through this engineering task, like what is a convolution, what is a pooling, what is a filtering means convoluting, and why we are doing convoluting. Then go for these applications. Okay. So it's good that a lot of tools are available. Theano was the one tool. TensorFlow mostly powerful because that is developed by, designed by Google, and mostly it is used in production purpose. So it is popular. But when I started my PhD, at that time also TensorFlow was not developed, because in 14 I used this Theano, and at that time I loved with Theano also. But obviously after TensorFlow, obviously world is going to the TensorFlow. So TensorFlow designed, developed by Google in 2015. Then again, to use that TensorFlow, it requires overall knowledge or skill of deep learning. But they developed one solution, provided additional library like Keras. Rather than as a programmer, you consider it as a API. API means interface, application program interface. So it will become easier for the programmer. We just use this API, and that API will call the TensorFlow functions. Another library is a Torch. This Torch is developed by these people. Mostly in Facebook, they use this Torch. But mostly this Torch language is prepared by researchers. And if somebody is doing research in deep learning, I suggest him to go with TensorFlow as well as with Torch. Don't skip this, because if you do the task in Torch, you can able to visualize the network in detail. So as a researcher, you go with the Torch. But if you are doing only production work, means you are doing machine learning web services like tasks, your main focus is to provide web services rather than to invest time in machine learning, you go with TensorFlow, no issue. But as a user, my recommendation is that the task that you achieve with TensorFlow, try to do the same task using Torch. Rather than, I will give another example. If you are doing the any algorithm like bubble sort algorithm in Java, and same algorithm if you complete it in C, when you implement it in C, you will get each and every details rather than in Java. So like that way, if you do task in TensorFlow, mostly things will be hidden to you. But if you do it in Torch, everything will be get understood to you. Obviously, the time required to complete task using Torch will be more because it requires some skill or programming. Another language that is a cafe. Those who like C or C++, for these people, I suggested cafe. And I want to proudly mention that I used cafe also, Torch also, TensorFlow also. Means rather than I experimented all these. Actually, I have not done the great thing because as in my PhD work, I need to work with all these tools. But mostly people are using TensorFlow, Keras obviously, but in one line, I am recommending go with the TensorFlow and Torch also. And those highly ambitious, they can go with the Cap also. Not necessary to go now in using Theano because TensorFlow is doing the same task. What is Keras, what is Torch, Cafe already discussed. And another advantage is that Python supports all these tools. Rather than MATLAB is also supporting TensorFlow, Keras, Torch. If you like MATLAB, you can go with the MATLAB also. But as a researcher and considering future, go with the Python. And another difference is that whatever you developed in MATLAB, it is a license based. That is the advantage of Python also. Another advantage is that if you have GPU, powerful GPU, you can get advantage of that GPU processing. So to switch from CPU to GPU in Python is easier as compared to MATLAB. So though I'm suggesting use a Python. Okay. Not only Python, but somebody is very good in JavaScript. I'm saying JavaScript because JavaScript is comparatively simpler language. If you are compatible with JavaScript, now machine learning in JavaScript is also possible. There are many libraries available. TensorFlow.js. This library is specially designed for JavaScript users, developers. So if you are comfortable with JavaScript, you can go with the TensorFlow.js. But technically, performance point of view, in Python, you will get better performance. Means if you consider, if you go really technically, and if you measure the detection time, maybe 5 milliseconds may required in MATLAB, in TensorFlow.js, and only 1 millisecond will required in Python. So that will be the advantage of using Python instead of TensorFlow.js. But still, if you want, you can continue with the TensorFlow.js. Now coming to my task, just give me 1 minute. I want to take just 1 minute break till you just observe this diagram of typical deep convolution neural network that I adapted for my task to extract features and to classify the feature. Just observe for 1 minute. Okay, thank you. Madam, am I audible?
Yes, sir.
Okay. So now actually this is a background or theory behind the task. So we will now touch our main topic, that is an application of deep learning. So here is deep learning application in computer vision. So the task is input the image and output is expression. It will take the expression, whether it is happy, sad, disgust, angry, and so on. So in my task there are 6 classes: happy, sad, and so on. And input image is cropped of 48 by 48. So this is one input image, and output is a probabilistic output. Here you can see that it is equivalent to this. So this is the high probability that this person input is belonging to this class, and less probability as compared to this, rather than negligible probability with this expression. Rather than, in short, it will classify the expression or emotion. You can use either emotion or classification. And here input is a image. Now, already I discussed, this is the last layer, that is the fully connected layer. So output layer is connected to fully connected layer, and in between there are sequences of convolution layer and pooling layer. So in this architecture that I referred, mostly I used max pooling layer, max pooling and average pooling. There are 2 types of pooling layers. One is max pool and average pool. So mostly I adopted max pool. And here you can see that I adopted 3 convolution layers. 3 convolution layer. In the first case, I applied 32 filters. In second convolution layer, I applied 64 filters, and in this layer I applied 128 filters. So here you can see that 32, 64, and 128. And in all cases, I applied 3 by 3 filter. So I don't know what is expression related to angry, which are the features related to happy. I don't know. So what I will do at the time of training, it will get, training is what? It will go through 2 stages. One is forward propagation and another is a backward propagation. Forward propagation means what? Image will be provided, and in each convolution layer, it will do the convolutions parallelly to all filters, and then it will do the max pooling operation. Again, it will go to the another sequential layer, convolution layer. Again, it will go to the third convolution layer. Dot 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 dot. It will repeat through the layers, and finally, it will do the softmax classification, and you will get the output. And if that output is matching, because in the training you are providing input data as its corresponding classification. If it is matching, then okay, that weight parameters are correct. Otherwise, in backward processing, based on gradients, it's not my task now to cover that learning algorithm, but at least you recall that there are 2 steps. One is forward propagation and another is a backward propagation. In forward propagation, from input to output, and depending on error, difference between output and input, it will calculate gradient, and using stochastic gradient descent algorithms and any another optimization algorithm, it will go to the backward by updating the weights. So this is in one page, and you need to repeat this for number of pages or number. It is known as a echoes. That is the training. So for the given data set, you train the network using this forward propagation and backward propagation. And once your network is trained, you will get these parameters trained. And then you give the unknown image. That image will give the correct output. That is the task. But to understand that classification task, we touched this task of classification of expressions. Okay. So this is the demonstration. Actually, here image or video input, actually through webcam inputted the image, and Here actually it is not visible, but it will give the expression here. This is just screenshot of running. Actually, technically, this is the model that I selected, but already I discussed. But this way we can nomenclate this kernel. 2049 by 49 indicates what? The C indicates it is a convolution layer. Total 20 and output size is 49 by 49. So this is just a way by which a researcher can refer the convolution layer. So actually this is a CNN model architecture that is suggested by Hubel and Wiesel system, but this is just for the understanding. Now one more thing that I want to point here is that there are some classical CNN models already trained and available, which you can directly use. Those are AlexNet, VGG, ResNet. So there are 7 to 8 classical deep neural network model already designed and available for a specific task. For example, if you use this, I'm not sure, this AlexNet deep neural network model, it is used for this purpose. Okay, so you can use this, but you require some modification in this that is known as a transfer learning. But that is not part of my topic. But just I want to mention here is that instead of going from the scratch, instead of going to train your model, you can use the already designed the model, do some modifications, and you can use it. But it requires some processing part that is coming under transfer learning. So ordinary learning and transfer learning. In transfer learning, you are getting already designed the trained model and you are refining it. Whereas in plain learning, you are going from the scratch. So you are designing your own model. So which are the already designed available models? One is AlexNet, another is the VGG, then AlexNet also. Don't give example of RNN. RNN is required for different tasks. Recurrent neural network, it is different types of neural network. What is difference between type of neural network, DNN and models is you need to understand. So AlexNet, VGGNet, ResNet, and so on. So I'm not now able to recall it. So there are 7 to 8 different types of classical DNA models. So you can use those models, and using transfer learning concept, you can adopt it for your purposes. So now coming to our task, I used for 2013 data set, which is available on Kaggle. So that is the all of you are aware about Kaggle. So in that Kaggle, that for 2013 data set is available, and it is in the CSV file format or Excel file format, which has these main columns. One is class of emotion, then pixel values. Already I mentioned that image size is 48 by 48. So I think approximately 9,000 elements if you do 48 by 48. So these are the pixel values. And just to go mention whether I'm using it for testing purpose or training purpose. So I have these 3 columns. One is class, another is pixel value, and third is usage. And regarding distribution of the given data set, so the data set consists of these classes: angry, fear, happy, sad, surprise, and neutral. So out of some images, means here about 4,000 images are belonging to angry, 4,000 related to fear, and so on. And 4,000 approximately are neutral images. So approximately there are 33,000 images. Out of those, 28,000 approximately reserved for training and 3,500 reserved for testing. Rather than ratio is 70% and 30%. Okay, here it is 70% for training, 15% for testing, and 15% for testing privately. So total, you can observe here that 35,000, near about 35,000 images, 28,000 for training and 6,000 for testing. So randomly, I will pick the 28,000 images to train. Okay. And if you actually final output is like this way. If I provide this image, it will extract the pictures. It will provide those pictures to my model, and it will give the distribution into surprise. And these images corresponds to whatever it may be. And just for the fun, I created that emoji related to that expression. So this will be the input. Then we will generate our model, and we will get this output. So that's it. That is the actually what we can say that our problem statement and requirement. So we will go through the implementation, or not implementation, not possible. We will go through the demonstration part. So I'm closing this presentation and switching to the uh, demonstration part. Okay, just give me 1 minute to switch to it. Madam, my Jupyter notebook is visible.
Yes, sir.
Yes, sir.
Okay, all of you. Okay, okay. So first we'll go through the demonstration. Okay. So those who know the TensorFlow deep learning, they can understand it. But assuming that you are not, just you started learning this, so skip those not getting. So here we are importing some libraries required in deep learning. Here already I trained my network. And that network, obviously this network required near about 3 days with CPU and 7 hours using GPU. So already I trained it and store it in JSON format. Here you can see that JSON format. Those who are doing programming, they are aware about JSON format. And another thing is that the model is stored in H5 format. This is, you can see that H5 format. So that is the output of TensorFlow. When you your model, and when you save this model, it will store in H5 format. So already I trained my model on Kaggle, as well as one deep learning server available in our institute provided by CDAC. That is powerful system. On that system, I trained that network, and already I will demonstrate that part also. If you are interested, don't worry. But initially we will go through the output part, then we will go to the training part. Go with the reverse side, because quickly I want to go to the demonstration part. So the model already designed. Assume that I am using that model. So I will load the model. So this is the procedure to load the model. So the model is now get loaded, and I want to assign it to some another variable, that is the model. Now just I want to display the current Keras version and TensorFlow version. You can skip it. Then I want to load X values and Y values from my X means here image pixel values, and Y means corresponding to classification. Here there are 7 classes, 0 to 6. Then test data set, already I mentioned that I reserved 3,500 samples for testing, and the size is 48 by 48, and total number of channels are 1, because my image is not color image, it is a grayscale image. So if it is color image, make it 3. But that already I processed. So after processing, my testing X value total 3,589 images of size 48 by 48. Then I assign it to test and Y values. Okay. Then already I loaded the model, and here you apply the predictor function of this TensorFlow and provide the input X. So here I will provide the input all X test. X test means I want to test now. So I will take all these 3,589 images, and I will do it batch wise. Means actually that is the, once again it requires some focus on what is batch size, what is stochastic gradient descent, then batch wise. But that is not now part. But assume that batch size is 32, and we will get the probabilistic output. and then just for the processing part, I assign it to prediction array and true array. Obviously, y true means actually true value of the corresponding x value, and y predict will be the predicted value of the model. Obviously, if y predict is equal to y true, and if it is 100 back, your model is 100% accurate. But maybe it will give the accuracy 90%, 80%. Maybe because you cannot say that after deep learning your model will be 100% perfect. Any machine learning deep learning will not give your model 100%, but at least it should give the accuracy more than 80%, 70%. That is expecting. So y pred and y true, you get the difference, and that difference should be in the permissible range. Means it should be greater than 80% or 90%. And if it is less than 70%, you modify your model. So the model that you design is not good. So you need to make some changes and refine it. Make some additional layers of convolutions, filters, change the parameters, again train the model, and again test the model till and until you are not getting good accuracy, at least more than 75%. Then you stop, and then you can use that model. Otherwise, if accuracy of your model is less than 70%, it is useless. So depending on the task and the requirement, you design the model. How to design the model, that is the actually engineering task that we will see. But first we will see the how it is working. So now we will start the prediction. Obviously, it requires to input 3000 images. It will take some time, but okay, we will see how much time it will require. Till and time this star is there, wait, because it is in now processing. Now what it is doing, it is taking x means input image. It will pass through the all input layers, and it will get the output y pred. And okay, it's faster. So all 3589 images it process. Now we will see some image. Okay, suppose out of this I is equal to 1, you give me a image. Suppose I want to see the first image, and I will provide that image, and I will see the output of that image. Okay, so I will make this here, and I will press the enter. Now it is processed, and this first image is related to happy, and here okay, this is just for fun. I transform it corresponding to emoji happy. Now, no, I will provide another image. I is equal to 2, and then we'll see. So this is related to angry 55%, fear some percent, sad some, but mostly it is related to angry. So here corresponding emoji is changed to angry. No, I will give not 2. I will give 100 image. What is? We'll see. So the 100 images happy. Like this way it will work. Now here I have taken the images which is used for training purpose. So you will say that, sir, you are using the same images that is used for the training. Obviously it will work now. But to justify this, take another images which is not part of this data set. Obviously these images are part of the 2013, so you will say that it is giving correct result. No, take suppose you want to test another image which is not part of 2013. We will see. Okay, so this is one function that I adopted. Here you can see that one image happy face.jpg that is already there in my hard disk or in my drive. We will test with that. So here I will use that image, and here you can see that. So obviously this image is not part of 2013. It is externally provided. It is giving the happy, as well as it is giving wrong answer also. So 100% it is not correct, but at least this is something correct now. So this is the classification in happy. First phase is happy, and I'm not sure what is there, but it is false answering, like it is getting as like a face and try to give that fear. That is wrong, but at least okay. Now go to another. Suppose another example. Okay, so there is a 12 angry.jpg file. 12 angry men is a famous movie, classical movie. The input is from that photo, and if I provide this, you will get this. There are these 12 men, and it will detect the face, and it will detect the emotions. So sad, fear, whatever it may be, you can check. Overall, what I want to demonstrate is that Don't think that I'm providing the input images from the already provided data and we are getting. No. Rather than to demonstrate it, once again, see this. I will go through some 10 sample images from my data set and we'll check whether it is giving correct. So here actual label is happiness, predicted label is happiness. Actual label is neutral but predicted wrong. Anger matching. Okay. Input is sadness is matching. Means one times wrong. Okay. 2 times wrong. Here anger and neutral. 2 times wrong. Neutral anger 3 times wrong. Sadness is correct. Fear is also correct. Neutral. So out of 10, 4 times. Sorry. Out of how many? Out of 10, 3 to 4 times wrong. Means accuracy is 60%. Okay. Just for the demonstration purpose, it is okay. Then what you can do? You go through the network, you modify the network, and again improve the accuracy. Again, it will give the good accuracy. So this is the demonstration related to images. Now we'll demonstrate with related to real time, that is the video. So I will stop this notebook and we'll go through the task of getting the input video. And I requested one student here to provide his face and we will detect the image. Just to give me one minute to make those adjustments, because I want to stop this and I want to go to the that part. So, madam, is it visible?
Yes, sir. Yes, yes.
One student, and can you observe the expressions?
Yes,
So
sir.
yeah. So thank you that I want to demonstrate. So here input is a video now, real time. So here it is indicating happy 99%, then so and so on, because it is going dynamically. 50% happy, 30% neutral, or like that way. So that I want to demonstrate. So I demonstrated both real time as well as with the image also, still image. Then another thing that I want to demonstrate here is that how I train the network. So it will require still 10 to 15 minutes, and then we'll go to the question answer, and then we will stop. So we demonstrated working on still image, and just a bit. I want to, yes. So this is known as a versioning. So you can create a, virtual environment for as per your requirement in Python. So I switch to my, because I install those TensorFlow libraries and CV libraries, OpenCV libraries. So not to just not to maintain it safely, I created the version. Otherwise, I will get confused. So that is the techniques in programming. So here I will check. You can use Jupyter Notebook or Jupyter Lab, or you can use Visual Studio for development. No issue. Okay. So let us go through this. Skip this part because this is required in Colab. We import the libraries or required, include the libraries required Obviously, NumPy library is required, Pandas library is required, TensorFlow is required, Matplotlib is required because all display plot operations is related to Matplotlib. So don't worry, this is just as include the libraries rather than it is equivalent to slash include stdio.e&c or import Java मध्ये काय आहे? Import काय असतं? Yeah. Import काय करता तुम्ही? Or you are using import command in Java also. Okay. So screen is visible.
हो का? हा का?
Hello, madam. Screen is visible.
त्या मागच गेलं का? मम्मीच्या हा ते मागच बघ.
Madam, screen is visible.
Yes, sir. The screen is visible, sir.
Yes. Okay, thank you. So file is here. You can see that for 2013 CSV file is there. So using this panda command pd.read CSV, you will able to read the image. Rather than we will see top 5 records by using the command head. So I will run this and you will see the output. Okay, so here you can see that output, there are 3 columns. One is emotion column, pixel value and usage. So here you can see that dot 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 because pixel values are separated by spaces. So there are total 4,000 approximately pixel values. So to display it, it referred first 10 to 12 pixel value. So here you can see that dot dot dot. Rather than this first row belongs to emotion number 0. This is belong to emotion number 2. Labels, no. 0 means what? 0 means anger.
Hello, Chavan sir. Your voice is not audible, sir. Chavan sir, are you there? Hello, Chavan sir, are you there?
Okay, so you change here and check the whether it is working correctly. Fine. So my this is converted into image array of size 48 by 48. Now it is ready to provide input to the our deep neural network model. Better we will see all few some images and we'll see what is the feature actually stored in the provided dataset. So this is the dataset provided by Kaggle. It's not Indian, it is provided by Kaggle. So this image related to anger, this image related to anger, discuss, and so on, so on. Okay, so just then we require some processing because I'm skipping this part because it is mostly related to the programmer. If you are interested, we can discuss in detail afterwards also. You can contact me anytime. We will go in detail. Then I converted into labels. Labels means emotions. Now, hence, focus on this point. Here, whatever the input set, I will split it into train part and testing part. Already you discussed, already I think it is known to you that whatever your data set, you suppose your data set have 100 images. Out of those 100 images, you train with 70 images and you test with 30 images. So some images you are reserved for training purpose, some images you are using for testing purpose. Now it is taking some time till we will discuss. So once again I'm repeating. You divide. Okay, it's completed. First I will because we will discuss by running this command. So here you can see that out of those total images, 32,000 images are reserved for training purpose and 35,000 images we reserved for testing purpose. So using the command extend.shape, you will get the this means what we can say that size, and here we have input images splitted into parts, train part and test part. Similarly, output is also divided into parts, y train and y test part. So this is the way by which using the command train test split, which is available by scikit, which is okay, import, where we imported. Okay, that is available in the imported library. Train underscore test split, image array, label, test size, 0.1. Here you can change the parameters if you want 40% testing images. So here is the using the shape command, you can get the size. And most important thing is that your pixel values are in the range 0 to 255, but to provide input, to process the input, it should be in the 0 to 1 range. So you divide each pixel value by 255 and that will done. Okay, then the major or the most focusing point is this. So here I created one deep learning model. So already I discussed, we use the Keras model, and here you can see that you use convolution 2D and flatten. So convolution 2D means I applied convolution, total 32 filters, 3 by 3 size, activation mostly ReLU, and input shape because input initially is 48 by 48. And done whatever the output, I created one more another layer where I applied 64 filters. Again, I apply 128 filters. So like this way, I designed the deep neural network model using Keras and TensorFlow. So this is just technique. It is not difficult. After some focus or some study, you can also able to design your own model. To visualize this model, use the summary command, and here you can get it in detail. Sorry, I not executed this. So here you will get the summary of that. So here also you can say that first layer is convolution layer, which has input 46 by 46 and 32 total what we can say the filters, and you can measure the total number of parameters. Total number of parameters means total number of weights that you want to learn. Obviously you required how many 32 into 3 by 3 now, because filter is 3 by 3, filter is 3 by 3. So for one filter you require 9, and like this way you require 32 times. So 9 into 32, you will get what? 9 into 32? 9 into 9, huh? 1? 280. So 32 into 3 by 3 will get 280 plus y40 because you require bias inputs also now. This 32 bias input. So that figure is 320. Then this convolution output is provided to pooling, and what the pooling will do, this 46 by, why now 46? Because 48 by 48 is input image, but after filtering 3 by 3, 48 will become 46 now, because already we referred that example. 6 by 6 will become 4 by 4, means it will reduce by 2, first row and last row, and first column and last column. So 48 by 48 will become 46 by 46. Then after max pooling, it will reduce the size by half, because max pooling means it will make the half size, half scale. So 23 by 2. But here you can see that number of parameters are 0, because in max pooling it is a simple mathematical operation. It is not necessary to train the parameters. In convolution, you require the parameters. So again, this max pooling is provided to the next. After this pooling, again it is provided to the next layer of convolution, and so on, so on. So in convolution, I required 320 parameters. Here 128 parameters, 180, and lastly, you can see that there is a dense layer. Dense layer is nothing but fully connected layer, and I required 7, because my output neurons will be 7 now, because there are 7 classes. So in last layer, I required 903, and as it is fully connected last layer, so huge number of parameters required in the last layer. So these are the number of parameters required, and here you can get the summary. Total number of parameters required for this small model 3,56,000. Out of those, only 448 parameters are non-trainable, means it is not necessary to design, but we need to design 3,50,000 parameters approximately. So in one training iteration, you need to train 3,56,000 parameters for this designed network. And like this way, you required different iteration, so it will take the time. Okay, so training will take more time. Now just for example, we will see how to train this network. Now this network is now designed. Now using the compile command, here you can see this compile command, using the optimization technique you can learn in deep learning. Here you can see that RMS prop is the evaluation criteria, and so on, so on. And I'm interested in accuracy, so I want to improve the accuracy. So you provide this parameter. It's not possible to explain everything regarding this programming, but at least assume that we will make the model parameters adjusted. Then hello. Okay, so I will create a model. I will give here names, for example, AISSMS. Okay, so now it will try to train the model. Okay, so file is adjusted. Now here total number of epochs provided 50. With total number of epochs 50, it will give the accurate result, but it will take some time. So to save the time, I'm making here 20 only, but it will give the less accuracy. But for just understanding purpose, or for going quickly, make the epochs 20. Now it started training. So here, okay, still it is quicker. So it will take total 20 epochs, and here you can see that model accuracy. You focus on accuracy. After each epoch or each iteration, it will improve the accuracy. So this is the first epoch. Like this way, it will go through all 20 epochs. It will take the training data set. Then it will go through the our convolution layers, pooling layers, fully connected layer, depending on output, actual output, and computed output. It will go through the backward page, and it will update the parameters. So these stages will be repeated now in this case 20 times. So just wait for 5 minutes only. I think it will take only 5 minutes to train the network. But simultaneously focus on here. So first epoch is now completed. Now second epoch started, and you can see the validation accuracy is now increasing. And simultaneously you can observe that loss should be reducing. Maybe after some epochs, if it is not improving the accuracy and not improving loss, then you can stop. Otherwise, your model will become overfit. So these are the tasks that is expected from machine learning engineers or deep learning engineers. So here is the great scope. You can modify this model, make it changes and achieve the better accuracy. But let us see with this simple model what accuracy I am getting. Okay, let us see. So here you can see that initially it was 36% accuracy. Now it is after second epoch, it changed to approximately 50%. Okay, so now epoch second is completed. Now epoch 3 is started. Just give me 2 to 3 minutes. Then all those epochs will complete and we will verify with this design the model. Obviously, you can't expect more accuracy because I trained it 20 times. If you trained it 50 times, you will get still better accuracy. Madam, is it visible?
The code is visible, sir. The down portion where the image is there, that is not visible.
No. First we will complete. Yeah, first we will complete this training part, then we will go through that part.
Yes, sir, that is visible.
You only focus on this part because it is now training is going on. So once training is completed, then we will use the model.
Okay, sir. Okay.
Yeah, just it is now up to stage fourth epoch. So we will wait. So I will take a pause for 2 minutes till you can give instructions to other instructions to participants, if any. Because it will require still 2-3 minutes now.
Okay, sir, no problem, sir. You carry on, sir.
So as per the plan, I'm trying to cover it within 2 to 5 minutes. Okay. So madam, it's 3:48. So we will finish by 4, and then I have another meeting. So I will leave. Okay, after 4. Is it okay, madam?
Okay, sir. Yes, sir. Once your meeting is over, I just want your 2 minutes. Then you can leave, sir.
Yes.
Okay, sir.
Till time, any query or question? Related to this implementation or theory? Okay, you may send queries to my email ID also afterwards, or you may contact me directly also on my mobile. No issue. But suggestion is that initially go with some machine learning in Python, and then go with the deep learning using TensorFlow in Python. So here you can observe that it is mentioning also after each epoch accuracy improved from 49 to 49.845. Slightly there is a improvement. So like this way it will repeat at least 20 times. Okay. Still it is going on 7th epoch, and this is for this model. Okay, but if your model is complex, again it will require more time, but there is no alternative. Training will require time. Obviously if you trained vast topic, it will require more time to train. For the simpler task, it will require less time. So depending on the task, depending on the model, it will take the time. So these are the parameters you can modify. If you are not getting good accuracy with number of 20 number of epochs, you can change it to 30 and then check. Okay. So once again, I am repeating till time. Input is training data set. X is input, Y is the output. So what is X and what is Y? So once again, go through quickly. So CSV file, X is this pixel value, Y is the emotion. So this is X and this is Y. X is input image, Y is corresponding emotion. So this is some pre-processing task. Using pre-processing task, what we separated X trend and X test. What is train and test set? For a given input data set, you divide that data set into training set and testing set. 70% data set you reserve for training purpose and 30% you reserve for testing purpose. So using these commands, train, test, split. This is the Python command. You can split data set in training part and testing part. So that will be very simple in machine learning implementation using Python, as well as in deep learning implementation in Python. So here, depending upon your requirement, you can divide the test set into 70%, 30%, sometimes 80% and 20%. Another important thing is that your pixel values are in the range of 0 to 255. Actually, when you get the input image from your scanner or any device, input image device or camera, the by default pixel values are in the range 0 to 255. But when you process in machine learning algorithm, that range is very high. 0 to 255 is range high. So transform those pixels in between 0 to 1. Then mathematically it will become compact. All of you are aware about microprocessor representing integer number of between 0 to 255, and if you have number between 0 to 1, it will be simpler to process 0 to 1. So what we'll do, you divide each pixel value by 255. If you divide each pixel value by 255, obviously range 0 to 255 will get reduced to 0 to 1. In short, each pixel value is now in the range 0 to 1, and that we have done by dividing by 255. Then what we have done, we designed a model. Model means deep learning model. How we design the model? Using TF. TF is what? It is import TensorFlow as TF command. Here you can see that import TensorFlow as TF command. Sorry, once again I want to show here now this trend test split that library is available from sklearn. So this TF is TensorFlow. So see here, TF dot keras dot models dot sequential. So these are the what we can say that methods that you need to use from the TensorFlow library. TF dot keras dot models dot sequential, and here I have 3 layers, convolution layers, 1 layer, 2 layer, and 3 layers. Now here you can see that it is not difficult to understand. What layer I want next layer? Convolution. So here give CONV 2D. Or mostly cases it is a 2D because image is 2D. And if it is a for video, you give here 3. So give here dot CONVD. Here also gives dot CONVD. Then I want 32 number of filters for the first layer. Refer the diagram that I presented in presentation. So in the first layer, first convolution layer, I require 32 filters. So pass that parameters. In the second, I require 64 filters. In third, I required 128 filters. Then provide the filter size. I required filter size of 3 by 3. If you require 5 by 5, change here 5 by 5. Here also I require 3 by 3, 3 by 3. Then next important task is activation function. Now in neural network, you learn that there are different activation functions like what is that activation functions? One is a threshold activation function. Then another is that softmax functions, ReLU functions. So you used here ReLU function. Okay, so which are different activation function and why ReLU function is mostly applicable in deep learning? Again, go through that study in detail, and you will get the understanding of why ReLU is the mostly applicable activation that is adapted in deep learning. And another thing is, what is input to this layer? Input is 48 by 48. Okay. So this is the first layer. Then I created second layer. Automatically it will give the output from this first layer to the second layer. In the second layer, everything is same. Only change is 64 filters. So In the first layer, I applied 32 filters. In the second layer, I applied 64 filters. Then one again layer I added, that is a convolution layer, and where I have applied 128 filters. So in the first layer I applied 32 filters. In the second layer I applied 64 filters. In third layer I applied 128 filters. In each layer I apply filter of size 3 by 3, 3 by 3, 3 by 3. Depending upon requirement, you can change these parameters, you can design these parameters, but it requires practice and study and detailed science of working behind it. So it is having great scope to design your model. Here is mostly engineering task is required. One thing that you notice that after each convolution layer, I applied a pooling layer. So here you can see that I applied max pool of 2 by 2. What 2 by 2 indicates? I will rescale it by half. I will rescale it by half, or it is known as, in another word, downsampling. Means what? Suppose your image is of size 100 by 100. What I will do? I will make it by 50 by 50. I will make 100 by 100 to 50 by 50. That is handled by this max pool layer. So in each block, you can see that there are 2 layers, ReLU and max pool. And like this way, we repeated this 3 times. And then the last layer is a fully connected layer. So to the fully connected layer, we will convert this sphere to flat. Convert this square to flat. Means what? If your square image is 10 by 10, you flat it to 100. Means you concatenate all rows and you will get one complete row of the images. So it will get the flat. And whatever that flattened vector you provide to the last layer. And last layer is known as a dense layer. So here we will provide it to 128. And again, we provide output layer of, here you can see that last output layer of having 7 neurons. Why 7 neurons? Because in my output, I want to classify it into 7 classes, 7 emotions. And here I applied softmax function. So either ReLU, softmax, or TANH function. These are different activation functions. Depending on requirement, you can use the functions. So mostly in convolution layer, you require ReLU function, and in last layer, mostly you require probabilistic output. So it is a softmax function. This is just for visualizing my model. Sometimes it is difficult to understand the model. Only programmer can understand the model. But with this command, you can get the summary of the model. Then what I have done, I selected the optimizer, because now this is the optimization step, because optimization is very important in deep learning. Without optimization, you cannot able to understand. So there are different optimization technique like gradient descent technique, stochastic gradient descent technique, Adam technique. So mostly you at least you start with gradient descent and stochastic gradient descent technique. So that optimization techniques is very useful in deep learning. But thanks to this TensorFlow command, using this command, you can apply that optimizer. So just assume that this is the optimizer selected. Then using fit command, you start the training the model. So only now we fortunately we reached to the 17th epoch. Just 3 epochs remain. Here you can see that accuracy changed to 98%. Initially it was 36%. So as epochs is increasing, accuracy is also increasing. So here, don't believe on me. I am demonstrating here lively that my model is giving the good accuracy. And another important thing is this model is not so complex. It is just having 3 layers. But if you again increase the layers, again it will give the more good accuracy. But it's not so simple, because sometimes it maybe get saturated. No? Means for training it will give the accuracy, but here you can see that for validation the accuracy is not improving. No? So here you can see that value accuracy improved from 51% to 52% at 10th, but after 11th it is not improving. It is not improving validation accuracy. This accuracy is increasing, but this accuracy is related to training accuracy. Means what? Suppose you are teaching some mathematics subject, and you solve 100 questions in the class, and you put 20 questions from that 100 questions that you referred in class. Performance will be good. But if you put another example which is not already solved in example, your class performance will not be good. So that is the validation accuracy. Training accuracy means what? You trained with samples, and at the time of testing, you are getting the one sample which is already trained and getting the result. Accuracy will be good. But you give the another input which is not part of the trained data set, whether it is working correctly, then you can say that it is accurate. So here I can say that my validation accuracy is 51%. So it's not good, but just for demonstration purpose, it is 52%. But if I trained with 30%, again that accuracy will increase, but it will take time. So we will stop with this 20 accuracy. Now here you can see that my training accuracy is near about 99%. The loss is 0.05. So it should trends to 0. And let us observe only 400 samples are remaining. Up epoch 20, okay. And here you can see the what we can the status, progress status, and okay. So accuracy, training accuracy is increasing. That's not issue. But important point is value accuracy is not improving. So what I want to do, I want to modify this model. So this model is not good, because though I am increasing my epochs, I'm not getting good accuracy. So I need to make the complex model. But anyway, we will check whether it is working correctly. So overall, the accuracy is here 51%. Means my model is not accurate, but at least 51%. Now I will apply this. Yes, okay, see here happiness, but actually it is surprise. Okay, surprise, it is okay. Happiness is working. Here sadness, wrong. So 2 times wrong, 3 times wrong, 4 times wrong, 5 times wrong. Here it is correct. Here it is not correct. So here you can see, okay, it will repeat 40 times. So we don't have time. So here you can see that why I'm getting wrong more than 50, near about 50%, because the model that I trained for here is accuracy is 51%. But if I train with another model, I will get good accuracy. So here you have great scope. You can change this model and design the good model which will give the better accuracy. Actually, in my research, I referred resonate model, and with resonate model, I obtained accuracy near about 72%. And that with that accuracy, I demonstrated that previous example, and that was working fine near at least 70% times it worked correctly. But here it will work only for 50%. So this is the means what in short demo that I want to share with you. I tried my best to provide input background as well as some theory behind it, as well as try to demonstrate it. Hope it will have input to you, as well as it will be useful to motivate to or to start research in this region. And with this, assuming that as there is no query or no question, with permission of the organizer, I want to stop or pause here. Am I, madam? Thank you.
Okay. Thank you so much, sir. I would like to convey to all the participants, the forum is open for the question answer session. If you are having any queries, please feel free to ask the questions. Chavan sir, few of the participants, they were asking for your email ID and phone number. So with your permission, can I share that your email ID and phone number with them?
Yes, madam. Yes. So, please.
If any of the participants, they would like to give the feedback, they can unmute themselves and they can speak also. It will be a great pleasure for us.
Notepad visible.
Yes, sir. Notepad is visible, sir.
Madam, is it visible?
Yes, sir. It's visible, sir. I again would like to request to all the participants, if you are having any queries, the forum is open for the question answer session.
Okay, thank you, madam. Okay, thank you.
Okay, okay. Thank you so much, sir. So I would like to express my heartfelt thanks to Dr. Umesh Chavan, sir, for sharing your valuable knowledge with us, sir. The concept of convolution, deep convolutional neural network, CNN model and architecture, use of Jupyter are truly helpful, sir. Also, how to calculate the number of parameters required. That part is also very well explained, sir. Creation of or designing of a model at the basic level is that also we found it to be very fruitful. Thank you so much, sir. Once again, you cleared our basic concept in a very well manner. Once again, thank you so much, sir. Uh, I also want to extend my thanks to our principal and convener of this FDP, Dr. D.S. Burmane, sir, HOD of E&TC and co-convener of this event, Dr. S.B. Dhonde, sir, and coordinator of this FDP, Mr. S.B. Dheke, sir, and Mr. V.B. Gavai, sir, and to all dear participants for your patience listening. Thank you, everyone, once again. I request all the participants to take out some time and give your valuable feedback on for this session. Link is already provided in the chat box. And I would like to convey to all the participants that the certificates will be sent to you on your email ID within a week. Thank you once again, everyone, and have a nice day ahead. Thank you so much, Chaman, sir.
मेरा ग्रुप
एक ही ग्रुप है।
दिवस वो चेक करती हूँ डायरी।
हाँ डायरी तो सही।
तो जरूरी क्या है कि
हाँ क्या अभी हाँ लास्ट पेज में आ गए तो
नहीं कल वो
आज नहीं है कैंपस के लिए